Let's take a look at another scenario here. We'll look at a more complicated one. We'll use the same lab setup I have there. This time we're going to give the networks on F02 on router A and B actual names here or numbers. So here's our requirements. The Linux server over on our server network 192.168.42.0 runs scripts to modify sensitive data within our network. The administrators that use this have workstations at 3 locations. One of the workstations is 172.1930.96. The other one is 10.10.0.55, and the third is 10.20.0.5, and these all require just SSH access. Additionally, the web server should be accessible on port 80 by all networks listed or not, except for network 10.10.0.24. For whatever reason, management has decided that 10.10.0.0/24 network should never ever have access to the web server. Why? I have no idea. Absolutely none. Maybe you have an incompetent manager that told you to do this. Maybe we have some goofy requirements. Maybe there's a legitimate reason. Maybe there isn't. It doesn't matter here. I'm literally making up these requirements so we can build an interesting access control list. Next, all networks need to access the DNS server for name resolution on port 53 only. And then last, we're going to choose the most effective place for the access control list to exist, and then write the access control list, ensuring all other traffic not explicitly listed above is denied to the server network. So we're going to allow all the stuff that we've listed above. Anything that's not explicitly stated there, we are going to deny that traffic from getting to the servers on the server network. So what I'd like you to do is do this on your own. Use the requirements we set forth in the extended access control list module. Use this chart here to fill in all of the pieces that we need to make this access list work, which means that you're going to choose a location and a direction for your list, and then you're going to write the criteria for the list in this chart, and we can then use this chart to build the syntax so that we can apply it to the router. I'm going to give you some time to do this. Pause the video, use the requirements that I listed in the previous slide and this chart, come up with your best guess at how we should apply this list, and then we're going to go through and take a look at what the right answer is. Let's take a look at what we got. So here's our scenario. Where should we apply that access control list? Well, based on Cisco's requirements, what Cisco says is that extended access control list should always go as close to the source as possible. And here's another case where I explicitly disagree with Cisco. Because if we wrote the access list and applied it as close to the source as we possibly could, we would have to write 3 separate unique access control lists and manage those 3 separate access control lists separately so that anytime there is a change on our server subnet, we're not modifying 1 ACL, we're modifying 3. This is terribly inefficient, and it's another case where Cisco's rule about applying extended access control lists as close to the source as you can really creates an inefficient, messy, and inappropriate use of our access control list. So my point to that is, on your ccna exam, memorize with fury those rules that standard access control list goes close to the destination as we can get them, and that extended access control list goes close to the source. But then when you work with access control lists in the real world, you're going to ignore those rules entirely, and you're going to apply the access control list where it makes the most sense. So in my case here, what I've done is I've chosen to apply the access control list in the most effective position, since all of the control of the traffic that we're doing is to and from the servers. I'm going to apply my access control list on F01 in the outbound direction. Does this violate the Cisco rule? It sure does. Does it solve our problem appropriately and efficiently? Yes, that it does. And from my perspective, I am much more interested in being an engineer and solving problems with my brain and logic than following some old antiquated rules that Cisco set out for us But just make sure that on the ccna, you memorize those rules and use them to pass that exam to demonstrate to Cisco that you know how to memorize a rule that you'll never use. You can see how I feel about this. Let's move on and solve this problem now. So we're going to apply it to F01 in the outbound direction. If your ACL is not applied there, that's okay. If you can set up this little network to test it out, awesome. If not, let's go take a look. If you didn't do that, go back and rewrite your access control list so that we can apply it to F01. So pause the video, fix up your ACL, and then you can come back and we can follow along here. So what I've done now is I have created the rules, pretending I'm somewhat of a newbie, trying to figure out how these access control lists work. So me as a newbie student, I filled out my chart as best as I could based on the requirements. And now I know there's lots wrong with my access list. So let's take a look and find out what we can do to resolve the issues. So one of the requirements was that I can SSH to the server at 192.168.42.22 from 172.19.30.96, 10.10.0.55, and 10.20.0.5. So if we take a look at that first line, when we SSH to a device, and we're coming from my workstation at 172.19.30.96, going to 192.168.42.22, and I want to SSH to the 42.22 address, my source port is going to be unknown because it's going to be ephemeral, and my destination port is going to be 22. So what I have right now is my source port and my destination port values are reversed. So this is a very common error for newbies, that we end up putting the port that we're using for our service, in this case SSH on port 22, we end up putting it in the source port spot for some reason, and that's just not going to work out for us because we will never have a source port of 22 when we're trying to SSH to some other IP address. So let's correct that. We'll flip-flop the source port and destination port here. And then we notice the other three rules here. We were consistent, but they were still incorrect. So we're going to flip-flop those as well. So now we've made our destination port 22, which is what SSH is listening for on our server at 192.168.42.22. Let's take a look at our next line here. This line says that we want to allow any device to communicate with our web server on port 80. Well, here this is completely incorrect again. If we're applying it to fast Ethernet 0/1 in the outbound direction towards our servers on router B, what we should think about is that we'll never have a source IP address of 192.168.42.80 leaving router B. The only way that 192.168.42.80 is going to encounter F01 on router B is if it's coming into the router, it will be the source. And if it's leaving the router, it'll be the destination. Since we're filtering traffic as it leaves the router, our destination and source are flip-flopped here. Now we've corrected that line to allow any traffic from any device on any source port number to access our web server on port 80. That line is corrected now. If we go to our next line in the access control list here, this is our deny statement saying deny access from 10.10.00/24 to our web server on port 80. Except there's a problem with this because our deny statement is coming after our permit statement. Our permit statement is going to allow traffic from 10.10.00/24, and then our second line denies it. We'll never ever get a hit on this second line. So what we need to do is we need to reverse those two rules. So we need to put the deny statement first and the permit statement second. So when we flip those two rules around, now we get what management wanted to deny 10.10.00/24 to our web server and then allow all other traffic. So we really need that deny statement to exist before our permit statement for that particular scenario. Well, let's take a look at that next line of our access control list now. Here we have permit TCP any with a source port of 53, destination IP address of our DNS server to destination port of any. Once again here we made an error with our source and destination ports being flip-flopped. And there's one other error here. I don't know if you caught it or not. Remember from our previous video on TCP and UDP. I showed you an example at the very end showing that DNS uses UDP in order to be much more efficient than using TCP. Typically, when we're doing DNS requests, it's just one single message saying, hey, what's the IP address for this website? And then the DNS server replying saying, here's the IP address. That way, using UDP, we don't have to go through the three-way handshake and four-way disconnect to send two messages. So we save 7 messages exchanging in order to resolve our address using UDP. So our protocol is wrong here. And additionally, we're never going to have a DNS request with a source port of 53. It's always going to be the destination port of 53. So here we flip that. We're going to change our protocol to UDP. Source address can be anything. Source port can be anything. Destination IP address is 192.168.42.53, and then our destination port of 53. And then our last line there is deny anything else. If we convert that to an access control list here, I've labeled this as an extended named ACL. I've called it server access, and I've written the lines out as follows. Now, what if we want to add ICMP echo request services to our server network? Meaning, what if we want to allow ping messages to leave our workstation, hit the server, and return again? So what we'd have to do is add a line for that. One of the ways we can do that is simply to add a couple rows to the end of our list here saying permit ICMP from any source. Source ports don't apply here because ICMP does not use TCP or UDP. Our destination IP address is 192.168.42.0 with 000.255 as our mask. And then in the destination port here, I cheated a little bit. There is no destination port. However, with ICMP, we can actually specify that we want to only select echo request messages instead of all of the ICMP messages. This way, we're just limiting it to ping requests and nothing else. Since our deny statement for everything is coming before our permit ICMP statement, what we'll have to do is we'll have to push our permit ICMP statement before our deny any. And then when we rewrite our access control list, we have that permit ICMP any source to a destination of 192.168.42.0. And then that very last word there, echo, is saying allow echo request messages through the router onto the server subnet.